This video demonstrates the operation of a relay switching operation. With a switch open, coil CR1 is de-energized. The circuit to the green pilot light is completed through normally closed contact CR1-2, so this light will be on. At the same time, the circuit to the red pilot light is opened through normally open contact CR1-1, so this light will be off. When the switch closes, the coil is energized. The normally open contact, CR1-1, closes to switch the red pilot light on. At the same time, the normally closed CR1-2 opens to switch the green pilot light off. This video demonstrates how a relay is used to control a high voltage with a low voltage circuit. The coil and contacts of the relay are electrically insulated from each other. The relay's coil is energized by the low voltage 12-volt source, while the contact interrupts the high voltage, the 240-volt circuit. Closing and opening the switch energizes and de-energizes the coil. This in turn closes and opens the contacts to switch the lamp load on and off. This video demonstrates the operation of an SSR used for control of DC loads. The LED section of the relay acts like the coil of the electromechanical relay and requires a DC voltage for its operation. When the input control switch is closed, a voltage is applied to the LED, switching it on. The light from the LED on the base of the transistor turns the transistor on, allowing current flow to the lamp load. The transistor section of the optical coupler inside the SSR is equivalent to the contacts in a relay. Because solid-state relays have no moving parts, their switching response time is many times faster than that of electromechanical relays. For this reason, when loads are to be switched continually and quickly, the SSR is the relay of choice. This video demonstrates the operation of an on-delay relay timer circuit. When the switch is closed, power is applied to the timer coil, but the contacts are delayed from changing position. With the switch still closed after the 10-second timing period, the normally open contacts, TR1-1, close to energize load 1, and the normally closed contacts, TR1-2, open to de-energize load 2. If the switch is then open, the coil de-energizes immediately, returning both time contacts to their normal state, switching load 1 off and load 2 on. If the switch is open before the timing period is complete, the time contacts do not change state. This video demonstrates the operation of a conveyor motor warning signal circuit with an on-delay timer. Coil CR is energized when the start push button is momentarily actuated. As a result, contact CR closes to seal in the CR coil and energize timer coil TD and establish the circuit to sound the horn. After a 10-second time delay, normally open timer contact TD closes to energize the motor starter coil M to start the motor and turn off the horn. This video demonstrates the operation of an off-delay timer with both instantaneous and timed contacts. Some types of timer relays come with a combination of timed and instantaneous contacts in both normally open and normally closed configurations. The instantaneous contacts are controlled directly by the timer coil, as in a general-purpose control relay. When power is first applied, through limit switch LS open, motor starter coil M1 is energized and the green pilot light is on. At the same time, motor starter coil M2 is de-energized and the red pilot light is off. When limit switch LS1 closes, off-delay timer coil TD energizes. As a result, time contact TD1 opens to de-energize motor starter coil M1. Timed contact TD2 closes to energize motor starter coil M2. Instantaneous contact TD3 opens to switch the green light off, and instantaneous contact TD4 closes to switch the red light on. The circuit remains in this state as long as limit switch LS1 is closed. When limit switch LS1 is open, the off-delay timer coil TD de-energizes and the time delay period is started. Instantaneous contact TD3 closes to switch the green light on, and instantaneous contact TD4 opens to switch the red light off. After a 5-second time delay period, time contact TD1 closes to energize motor starter M1, and time contact TD2 opens to de-energize motor starter M2. This video demonstrates the operation of a one-shot timer circuit. One-shot timers are used when it is required to have an input signal of any time duration trigger a device or operation for a specified preset period of time. This scenario is an application of a one-shot timer used to energize a solenoid valve for exactly 10 seconds, regardless of the switching time cycle of the proximity sensor. The proximity sensor is positioned to detect the passing of a product. When the product passes the proximity sensor, the sensor's contact provides a trigger signal that changes from open to closed and back to open. The timer's output contact closes, causing the solenoid valve to be activated and the one-shot time delay relay to begin its timing cycle. The output contacts remain closed and TD continues to time for 10 seconds. Only when TD has timed out does its output contact open. After timeout, the one-shot is ready to be re-triggered for the next cycle. This video demonstrates the operation of a symmetrical recycled timer flasher circuit. The contacts of a recycled timer alternate between the on and off states when the timer is initiated. For symmetrical timers, the on and off periods are equal. The length of the timing period is adjustable, but the time between the on and off operations remains constant. The time setting of this symmetrical timer is 1 second. The timer is triggered into operation upon closure of the high temperature switch. The timer's output contact closes and opens at 1-second intervals to operate the pilot light. The pilot light continues to flash on and off as long as the high temperature state exists. This video demonstrates the operation of a PLC programmed on-delay timer. This application calls for the pilot light to turn on any time the pressure switch closes for a sustained period of 5 seconds or more. The pressure switch is hardwired to input I3, address I03. The pilot light is hardwired to output Q1, which is address Q01. The associated ladder logic program has been entered using the front keypad and LCD display. When the pressure switch contacts close, the program timing output coil T1 at address T01 instruction becomes true, initiating the time delay period. After 5 seconds have passed, program timer contact T1 at address T01 becomes true, making the rung true. Output relay coil Q1 at address Q01 becomes true and energizes the pilot light. This video demonstrates the operation of a 2-coil latching relay circuit. In the unlatched state, the circuit to the pilot light is open, so the light is off. When the latch button is momentarily activated, the latch coil is energized to set the relay to its latched position. The coil contact closes, completing the circuit to the pilot light, switching the light on. Note that the latch relay coil does not have to be continuously energized to hold the contacts closed and keep the light on. The only way to switch the lamp off is to actuate the reset button, which will energize the unlatched coil and return the coil contact to its open, unlatched state. In cases of power loss, the relay will remain in its original latched or unlatched state when power is restored. This video demonstrates the operation of a battery-operated latching alarm circuit. Latching relays are used in applications where power must be conserved, such as a battery-operated device. This circuit uses a latching relay to conserve power. Regardless of whether the circuit is reset or latched, there is no current drain on the battery. Momentarily closing any normally open sensor switch will cause the relay to latch, closing the contact to power the alarm circuit. The manual reset button must be depressed with all sensors in their normally open state to reset the circuit. This video demonstrates the operation of an alternating relay. Alternating relays are used in applications where the optimization of load usage is required by equalizing the runtime of two loads. An external control switch initiates the alternating action. Each time the control switch is opened, the output contacts will change status. LEDs indicate the status of the internal relay and which load is selected to operate. Loss of input voltage resets the unit. Load A becomes the lead load for the next operation. An option feature found on these relays allows an operator to terminate alternating operation and cause only the selected load to operate. This feature allows users to select one of the two loads or alternate between the two. This video demonstrates the operation of an alternating relay circuit used with a duplex pumping system. In this application, two identical pumps are used for the same job. A standby unit is made available in case the first pump fails. However, a completely idle pump might deteriorate and provide no safety margin. Providing a motor control circuit that automatically alternates which pump operates with each start-stop sequence assures that both pumps get equal runtime. When the circuit is first activated, it energizes the first motor, M1. The circuit remains in this state as long as starter coil M1 stays energized. When the pump stop button is activated, the first load, M1, is turned off and the alternating relay toggles to the M2 operating position. When the circuit is again activated, it energizes the second load, M2. When this sequence is repeated, this process is repeated again. This video demonstrates the operation of typical inputs and outputs of a control program. Electrical control circuits can be divided into two separate sections consisting of inputs and outputs. Input signals initiate or stop the flow of current by closing or opening the control device's contacts. The input section provides the signals and includes manually operated switches, automatically operated flow, temperature, and limit switches, as well as relay contacts, as shown in this simulation. Outputs are load devices that directly or indirectly carry out the actions of the input section. The output section provides the action and includes contactors, heater units, relay coils, and indicator lights, horns, and solenoids, as shown in the simulation. A combination of input devices that either manually or automatically sense a condition and the corresponding change in condition performed by the output device make up the core of motor control. Relay coil CR is energized when the on-off switch is closed and acts to close the CR-1 contact and open the CR-2 contact. For the horn to be energized and sound, both the CR-1 contact and the limit switch must be closed. The solenoid is energized and operates whenever the CR-2 contact or the float switch is closed. When the temperature switch closes, the contactor coil energizes and acts to close the C1 contact. At the same time, the circuit is completed to the red pilot light, switching it on. The heater unit is energized and operates whenever contact C1 is closed. This video demonstrates the operation of an AND logic function. Logic is the ability to make decisions when one or more different factors must be taken into consideration. Control logic functions describe how inputs interact with each other to control the outputs. The AND logic function operates like a series circuit. AND logic is used when two or more inputs are connected in series and they all must be closed in order to energize the output load. In this application, both the temperature switch and the float switch inputs must be closed to energize the solenoid output. This video demonstrates the operation of an OR logic function. The OR logic function operates like a parallel circuit. OR logic is used when two or more inputs are connected in parallel and any one of the inputs can close to energize the output load. In this application, any one of the two push-button inputs can close to energize the motor starter coil load. This video demonstrates the operation of an AND/OR combination logic function. Control circuits often require more than one type of logic function when more complex decisions need to be made. In this simulated application, the output is a contactor coil that is controlled by combined AND/OR logic functions. Both the on-off switch and limit switch, in addition to the sensor contact or push button, must be closed to energize the contactor coil. This video demonstrates the operation of the NOT logic function. Unlike the AND and OR logic, the NOT logic function uses a single normally closed contact rather than a normally open input device. NOT logic energizes the load when the control signal is off. In this simulated application, the NOT logic function used to prevent accidental contact with live electrical connections. The normally closed safety switch operates by detecting the opening of guards, such as doors and gates. Contacts of the normally closed safety switch are held open by the shut door. When the door is open, the safety switch returns to its normally closed state and the trip solenoid of the circuit breaker is energized to remove all power from the circuit. This video demonstrates the operation of the NAND logic function. NAND logic is a combination of AND logic and NOT logic in which two or more normally closed contacts are connected in parallel to control the load. This simulated application is that of the NAND logic function control circuit of a dual tank liquid filling operation. The two tanks are interconnected and each is equipped with a float switch installed at the full level of each tank. A 3-wire control circuit is used in addition to the two parallel connected float switches that provide the NAND logic of the circuit. With either or both tanks below the full level, momentarily depressing the start push button energizes the motor starter coil, turning on the pump motor. Both float switches must open for the motor to shut off. The stop push button will shut down the process at any time. This video demonstrates the operation of the NOR logic function. NOR logic is a combination of OR logic and NOT logic in which two or more normally closed contacts are connected in series to control the load. This simulated application is that of the NOR logic function used with 3-wire control to energize a motor starter. For this application, the motor can be started from one location, but can be stopped from 3 locations. The 3 series-connected normally closed stop push buttons provide the NOR function of the circuit. Once the circuit is energized, if any one of the 3 stop push buttons is pressed, the starter coil M will de-energize.